everyone. Today we are going to solve the problem pattern searching. So it is a difficult easy question. So given a text and a pattern, the task is to check if the pattern exists in the text or not. So we will take the first sample input. So the given text, the first input is text equal to geeks for geeks. And pat is equals to geek. So let us first understand the logic. So now we can see, so this is the first sample input. So our approach we are going to use is it is a kind of sliding window approach. So we are going to use a type of sliding window approach. So we all know sliding window means we maintain a window of size, let us take in this example of size pat which is of 4. So we keep on moving this window over the text. So if anywhere the window matches the pat in our from the text, then it is found. So the output is 1. If it is not found, then the output is 0. So now what is our first step? So in the first step, we will take the size of text. So n is equals to comma m. M is equals to size of pat. So it is 4. So it is over the first step. We will declare the values. So now for I is equals to 0 to n minus m, because we will consider the windows like this. So let us write a set of windows what we will actually process. So for a size of 4, so they are the windows we are going to process. So if you see the windows, then the last string is present here. So if we want to see the window from the first index, right? So if you see the first index, then it is E character. So what is the place of E character? It is, we know the string indexing is also start from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this last string starting position is at 9. So if you do n minus m, then which is 13 minus 4. So it is 13 minus 4, it is 9. So like that. So now you can understand that how it is happening. So we will process from I is equals to 0 to n minus m. So for each iteration, So let us take like this. So let us take the iteration 1, first iteration. For I equal, for every I, we first take a variable j is equals to 0, and we will compare from I plus j and I plus j character. So the windows I plus j character should be equal to our part of j character, and j should be less than m, because j should be only going from the 0 to pat length. So until it is true, we will be increasing the j value. So if you see, after increasing the j value, if we will check if j is equals to the m, then it is okay. So like that. So now we will work out this with our one example, which is we wrote here. So for I is equals to 0, we will take the j is equals to 0 for the first iteration. So for the first iteration, j is equals to 0. Now we said we will compare. Now I plus j. So from the text, the character at 0, because we know I plus j is 0, so 0 from the text is equal to g, and the character from pat we denote as p, so pat of the j character is equal to also g. So is they are both matching, so yes. So we increment j value. So now j is equals to 1. So now t of 1 is equals to e, and p of 1 is equals to e. So they are matching. So j is equals to 2. So t of 2 equals to e, and p of 2 is also equal to e. So they are matching. So j is equals to 3, and t of 3 equal to e, and p of 3 equal to, sorry, it is k. So they are matching. So j is equals to 4. So when j equals to 4, we said j will only go less than the size of pat, which is 4. So the condition fails. Therefore we will check if our j value is equals to the m value. So j value is 4 and m value is 4. So if they matches, then that means that we found the substring or the pat string as a substring in the text. So the output is 1. So like that. So we take n and m variables. We start a iteration. For each iteration we do this process. So we take a j variable. So until j is less than the m, and also our text I plus j value and p of j value, until they both are conditions satisfied, we increment the j value. And when if j equals to m, then the output is true. So like that. So this is not a purely sliding window, but almost a sliding window approach only. So we can observe that. So because we are moving the window one step at a time forward, so it is sliding window. So this is the question. Now we will turn the logic into the code. So we take two variables. Text can be taken size as length. So after n and m, we said we will start a loop. So for I less than n minus m, we discussed earlier. So we said we will take a j equals to 0. So while our j is less than m value, and also the text dot caret I plus j is equals to pat caret j. So j plus plus. So at last, if j is equals to m, return 1. So if doesn't present, then return 0. So if you see the sample test case, it is passed. We are executing the hidden test cases. So you can see there is a small error. So our output is 0, but its correct output is 1. So if you see yu, so we should go to n minus m, not before n minus m. Small mistake. We are again executing the hidden test cases. So we can see they are passed. Now we will analyze the time and space complexity. So these two variables take big of one space. This one loop take n time, big of one space. This loop only in the case of the true case takes m time. And finally, highest time complexity is when not n. So for every n into n. So because for any one iteration, it will be executing m times. So n into m. I am telling the worst case, not the average case. Space is big of 1. So now if you compare, so you can see the expected complexities, we are more optimized in the terms of space, but a little bit less in the time complexity. But it still is submitting because it is acceptable and slightly variated from the expected one. That's it. So we can see we are using the sliding window approach, not too different but almost similar. Just we are not using an actual window, we are using a window size. That's it, using the j variable. So kindly go and practice the program. The program link is given in the description. Thank you for watching. Subscribe for more videos.